Artificial intelligence. It's a term we hear all the time, right? But what is it really? Like, how does it actually work under the hood? Well, that's what we're going to do today. We're pulling back the curtain and demystifying the whole thing. Let's get into it.
Okay, think about this. You just finished binge watching a show, and boom, your streaming service suggests something new, and it's perfect. How on earth does it know? Is it some kind of mind reader? Nope, not magic. It's actually something way cooler.
And this is a perfect example of AI in the wild. You know, these recommendation engines, they're basically learning from every single click, every show you watch, every choice you make. It's not just you, it's millions of people. And they find these hidden patterns to guess what you're going to love next. And think about it, it's not just for movies. It's your music playlists, your shopping recommendations. It's pretty much everywhere.
So yeah, it's clear AI isn't some sci-fi thing from the future. It's already here, woven into the stuff we use every single day. And to really get a grip on it, it helps to break it down into, let's say, 3 main flavors. You've got machine learning. That's all about learning from data. Then there's computer vision, which is basically teaching computers how to see. And finally, natural language processing, which is all about helping them understand us and how we talk.
Okay, I know what you're probably thinking. This sounds super complicated, right? But here's the thing. Building an AI project is actually more like following a recipe than writing a bunch of complex code. It's a step-by-step process, and it's surprisingly straightforward when you break it down. So let's make this super simple. Forget AI for a second. Imagine you're gonna make a greeting card for a friend. What do? Well, first, you get an idea, right? Then you figure out what you need. Paper, glitter, the whole deal. You gather your stuff. You actually make the card. You give it a once-over to make sure it looks good, and then you give it to your friend. Building an AI project? It's pretty much the exact same flow. It's a structured, creative process. Just like that.
And believe it or not, that simple greeting card analogy maps perfectly to the official AI project cycle. Getting an idea? That's just a fancy term for problem scoping. Gathering your materials? That's data acquisition. Making the card is what we call modeling. Checking for mistakes? Yep, that's evaluation. And delivering it is deployment. See? It's the same exact logic, just with some techier sounding names.
Okay, so let's get into the real heart of how most of this AI stuff works. It's all about a concept called machine learning. You can think of this as the engine room, really. It's the whole process of teaching a computer how to spot patterns and make its own decisions, without us having to spell out every single rule. We just feed it a ton of data, and it starts to learn. So how do these machines actually learn? Well, there are 2 main ways to go about it. First up is supervised learning. This is where you give the AI data that's already labeled. Think of it like giving a student a bunch of flashcards with pictures of cats, and every card is clearly labeled cat. The student has the answer key, right? Then you have unsupervised learning. This time, you just dump a whole mess of data on the AI and say, figure it out. It has to find the patterns all by itself. It's like giving that same student a pile of animal photos and having them sort them into groups without any help. And you can really see the difference here. On one side, you have the teacher, or the labels, guiding the learning process. That's your supervised learning. On the other side, the AI is left to its own devices, clustering the data into groups it discovers on its own. That's unsupervised. So 2 totally different approaches, but both are aiming for the same thing, creating an intelligent system.
All right, so we get that machines can learn. But how do they go from just knowing things to making an actual choice? You know, a simple yes or no decision. Let's zoom in and look at a really simple model to see how it works. So this little guy is a super basic AI model called a perceptron, and its entire job is to decide one thing. Should we go to the park? It looks at different inputs like, do I have a jacket? And is it sunny? And it gives them each a weight. Here, having a jacket and it being sunny are big pluses. The perceptron just adds it all up, and since the final score is positive, the decision is, yes, we're going to the park. But now, hang on. Watch what happens if we switch things up. This time no jacket, and it's not sunny out. We do have an umbrella, but the forecast is kind of gloomy. So the model does the math again with these new inputs, and this time the score comes out negative. So the decision is a big nope, we're staying home. See? It's the same exact model, but it came to a totally different conclusion based on new information. And that, right there, is the magic of AI in a nutshell.
All right, let's switch gears to another one of those AI flavors we mentioned, computer vision. And this one is pretty much exactly what it sounds like. It's all about giving machines the ability to see, to process and understand the visual world just like we do.
You see this in action all the time. Think about security cameras. Computer vision algorithms are what allow them to spot unusual activity or even identify things. But it's also the magic behind something you've probably used, Google's search by image.
You know, where you can drop a picture in the search bar and it tells you what it is. That's pure computer vision at work.
Okay, so we've taught machines how to learn and how to see. But what about understanding us when we talk? Well, that's where the third flavor comes in. Natural language processing, or NLP for short. This is the amazing technology that acts as a bridge between human language and computer logic.
Honestly, you use this every single day. Anytime you talk to your phone and say, "Hey Siri, set a timer," or ask Alexa to play your favorite song, you're tapping into NLP. That little device has to figure out your words, your grammar, what you actually mean by what you said, and then turn it into a command. It's a ridiculously complex process that for us feels totally effortless.
So at this point, you might be thinking, okay, this is all seriously cool, but there's no way I could ever build something like that. Well, I've got good news for you. That's where you'd be mistaken. Creating AI isn't just for programmers in Silicon Valley anymore. The barrier to entry has gotten so much lower, all thanks to these amazing things called no-code tools.
Let's take a look at a real-world example to see what I mean. Down in Antarctica, researchers have this challenge. They need to identify different species of penguins, which can be tricky. But look how they've scoped out the problem. They know who has the problem, what they need to do, where it's happening, and why it's important. What they really need is a tool, an AI, that could just look at their data and tell them the species automatically.
So the big challenge is telling these three species apart, the chinstrap, the gentoo, and the adelie. They all kind of look similar, right? But the researchers have data. They measure things like how long their bills are, the length of their flippers, and even which island they live on. So the big question becomes, can a machine take all that data, find the subtle patterns, and learn to tell them apart for us?
The answer is you bet it can. And here's the kicker. They can do it without writing a single line of code. This right here is a no-code tool called Orange. You literally just drag and drop these little blocks. You hook up your data file, you pick a machine learning model, and you connect it to an output. That's it. The AI does all the heavy lifting in the background, figuring out how to predict the species. It's not about coding, it's just about a logical flow.
So the big takeaway here is this. AI isn't some black box technology that's only for data scientists at huge companies anymore. It's becoming a tool for everyone. It's an accessible thing that anybody can use to solve real problems that matter to them, whether you're a biologist studying penguins in Antarctica or, a small business owner trying to understand your customers better. And that really leads us to one last really important question. As these incredibly powerful tools get easier and easier for all of us to use, who decides what the rules are? Who's responsible for making sure they're used ethically and safely when pretty much anyone, anywhere can build their own AI? That is something we all need to start thinking about. Thanks so much for joining me.